Question number 17. A stone is allowed to fall from the top of a tower that is 100 meters high, and at the same time another stone is projected vertically upward from the ground. So two stones are there, one that is falling from the top and one stone we are sending it upward or we are throwing it upward. So two different stones are there and this height is 100 meter. This height total is 100 meter. This tower is 100 meter and the stone which we are throwing upward from the ground with a velocity of 25 meter per second. So here initial velocity of this stone 2. This is a stone 1 which is falling on the ground and this is which we are throwing it upward. Its velocity, initial velocity is 25 meter per second. Now calculate when and where the two stones will meet. So when we are throwing both of the stone in same direction, so where they will collide with each other, at what point, at what distance, at what time, that we have to find out here. The only thing we have, that is 100 meter distance, that they are going to meet somewhere in between this 100 meter distance and the initial velocity of this second stone. So this is the stone 1 which we are dropping from the top and this is a stone 2 which we are throwing it upward. So both directions are opposite to each other. Now let us calculate for the stone 1 that stone 1, the initial velocity for stone 1 is going to be 0 because we are dropping it. Then final velocity we do not know that how much it will have a final velocity. Then so distance it will cover is 100 meter. Now G, in case of the stone 1 which we are dropping it, it is going to be 9.8 and it is towards the earth, it is in the direction of the motion, so this is going to be positive. Now let us find out first the distance for the stone 1. So S1 equals to ut plus 1/2 at square. Now time we do not know that how much time it will take to meet the second stone, so we are going to keep this time as t only. So here u is going to be 0, so this term will be 0 because u is 0, so this term is 0. We will get here 1/2. A we are going to take 9.8 and t we do not know that it is t square. So this is for the stone 1 that we are dropping it from the top, that half 9.8 t square. So S1 we are going to get 4.9 t square. Once we will divide this 2 with 9.8, we will get 4.9. Got S1, that is 4.9. Now for the stone 2, we are going to find out the same thing for the stone 2. Now stone 2 we are throwing it upward, so it has initial velocity that is 25 meter per second. Final velocity is going to be 0. Distance we know that it is going to cover 100 meter distance, but we need to find out that, and gravitational force we are going to take is 9.8, but that will be minus in this term because we are throwing it upward and that will be against the motion. So this 9.8 is going to be minus for the second stone. So similarly, as explained, when we are taking the distance for the stone 2 is equals to S equals to ut plus 1/2 at square. Here they have given 25 meter per second. So 25 into t plus 1/2, and this is going to be minus 9.8 t square because this is in opposite direction as explained and it is against the acceleration due to gravity. So this A's value and G's value is coming here negative. So here we are going to get 25t minus 1/2 into 9.8 t square. So 25t minus we will get the same, that 4.9 t square. So this we are getting it for the S2, that is stone 2, this equation we are getting, and for the stone 1 this equation we are getting. Now we know that for both the stone S1 and S2 the total distance is 100 meter. So we are adding this S1 plus S2 and we are writing equals to 100. Now when we are substituting S1 value and S2 value in S1 plus S2 equals to 100 meter, we will get this. Now you can see here 4.9 t square and 4.9 t square both are having opposite sign. So we can cancel out this two term. So we will get here 25t equals to 100 meter. So t equals to, we will get 100 divided by 25. So t equals to, we will get 4 seconds. So here we got a time. So that t's value we are going to put in this two separate equation, that S1 equals to and S2 equals to. So we will get a timings for the stone 1 and stone 2, that for that particular distance how much time they are covering. Now in this two equation we are going to put t's value, that t equals to, we know that it is 4 seconds. So equals to 4.9 into 4 square. So 4.9 into 16 we will get here. So S1, this value we have put in this S1. So S1 equals to, we get here 78.4 meter. So distance for the first stone is 78.4 meter. The same thing, we are substituting t equals to 4 seconds in this equation. So we will get 25 into 4 minus 4.9 in multiplication with 4 square. So here 100 minus, we will get 4.9 into 16. So we got here 78.4. And when we will subtract this, we will get S2 equals to 21.6 meter. So to tally the answer, we can just add 78.4 plus 21.6. So we should get 100 meter. So yes, when we are adding this two distance, we are getting 100 meters. This much distance both the stones are covering. Now when one stone, we are dropping it from the top. So it is covering 78.4 meter distance, and the stone which we are throwing it upward, that is covering 21.6 meter distance. And they are meeting in between when the first stone has already covered 78.4 meter distance and second stone has covered 21.6 meter distance. The time when the both stone will collide with each other, that time will be 4 seconds. That time will be 4 seconds. So hope this video has solved your doubt. In coming videos we are going to cover some important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.